last class, we have seen about probabilistic model, and we have seen language modeling also. Along with that, we have discussed about the text classification using naive Bayes classification, and also we have seen Bernoulli's classification. So today we will see our vector space classification. So last classification was based on probabilistic model. So this is based on vector space. So vector space classification. In vector space classification, here also normally we will be using two types of classification. One classification is Rocchio classification and the other one is KNN, K nearest neighbor. K nearest neighbor. So that classification also we are going to study in vector space classification. So here we need to know contiguity hypothesis. So documents in the same class form a contiguous region and regions of different classes do not overlap. Okay. So here the documents that belong to the same class, they will be in one region, and documents with other different classes, they will be in another region, so that the regions of different classes, they are not going to overlap each other. For example, in this, so UK is one class, China is one class, Kenya is one class. So we have three classes here. So this is the boundary. So this line, curved line which separates the two classes, the three classes, they are known as the decision boundaries. So this one we call as decision boundaries. So China does not overlap with UK. UK class does not overlap with Kenya classes. That's what contiguity hypothesis is. So it documents of the same class, they will be in one region, and for other classes it will be in another region, so that the regions of the different classes, they do not overlap with each other. As I told you, we have two classes here, two methods, classification methods. One is Rocchio classification and the other one is K nearest neighbor classification. So let us see some bit differences between the Rocchio classification and KNN, and we will start the calculation. Before we start the calculation, so let us just see. So Rocchio classification divides the vector space into regions centered on centroid or prototypes. So when you calculate for your classification, you have to calculate your uh, centroids also. That is the center. Okay, you have to calculate the center of the region also. Now, Rocchio classification, this calculation will be easy and it will be efficient, but sometimes the accuracy may be less. The accuracy you obtain may be less because if classes are not approximately this one, so if classes are not approximately spheres with similar radii, that means we are going to separate the regions with a decision boundary, and this decision boundary, when you don't find the radius for the region of all the documents with the center, then you may misclassify some documents in different classes. Okay, that's what the accuracy may be somewhat less if the classes are not classified properly based on the radius, because we are going to draw some regions for the classes, respective classes. So whereas in KNN, K nearest neighbor, this classification method assigns the majority class of K nearest neighbors to a test document. So here we are going to find the distance. We are going to find the distance with the label class and with along with the unlabeled class. So there will be some document values, some we are going to find the IDF values and all here. So with the IDF values, term, frequency, weighting and all we are going to find here. So after finding the weightage, that means the distance between the points, we will be assigning the majority class. So that we will discuss in the example. So first let us discuss about your classification. So this figure, it shows vector space classification into three classes. We have China class, UK class and Kenya class. So in two-dimensional space. And whereas the documents are shown in circles, diamonds and X. So for China, the document it is represented with the circle symbol, and for UK it is represented with diamond symbol, and for Kenya it is represented with X symbols. So the boundaries here, so this the curved lines which separates the two classes. This is known as the decision boundaries, or we can say the boundaries where it separates the classes. It may be three classes or two classes or more than more than one class. Okay, so when you have different classes, it will be more than one class. If there is only one class, then no need to have decision boundary. So if there is more than one class, then there will be decision boundaries. Okay, so to classify a new document, then so for example, star, you can see a star symbol here. So star symbol, this is an unlabeled document. So this document, we are going to classify whether it belongs to China, UK or Kenya based on your centroid and other classifications. So you see here. So centroid, as I told you in Rokyo classification, we need to complete the centroid which is the center of the document or the region. Okay, so this centroid is calculated using this formula. Mu for the class, so 1 by D for the class, summation document D belongs to the set of documents D and V vector. So this classification purpose, we need to find the centroid values. So DC, where DC is the set of the documents in D, whose class is C. So DC is equal to document D, and document D belongs to class C. So this formula we will be using. Then for vector, so for a document using vector space, we are going to represent the normalized vector of document D by using this symbol vector for the document. Okay, so V vector, and the boundary between the two classes is a set of points with equal distance from the centroids. Equal distance means we should have same radius. Okay, equal distance from the centroid. And for example, so this is given here in the figure, whose set of points is always a line. So we will see this symbol here. Okay. So we have A1 and A2. This distance. One second. Hello. Uh, uh, So here A1, A2, C1, C2, B1, B2. So they have equal distance because suppose this dot is the centroid. So the reason from this distance A1 and A2, this will be equal. Similarly, B1 and B2 is equal. C1 and C2 is equal. So it should have equal distance. That's what it is said here. Then after that we will be defining a hyperplane. So hyperplane, the equation is given like this. For hyperplane. So all this we will see the calculation here, and you will understand all the formulas given here. Otherwise, if I read out the formulas, you won't understand. So let us see the example, then we will understand all the formulas. So the same example I'm using here, this example we have been using for calculation of text classification using NetBayes and also text classification using one-on-list model. And now the same data we are going to use for classification using vector space. So in vector space, as we have here four documents is written here along with a test document T5. Then we have 3 yes classes and one no class like yesterday. Now here vectors and class centroids for the data. So already in this table, the centroids been calculated and also the term widths are calculated. How? So let us see here. For centroid, mu c, this is for centroid for yes class, and mu c dash or c bar, this is centroid for no class. So since we have two classes, yes class and no class, we are going to find the centroids for two respective classes. Okay, for yes class also we have to find centroid, and for no class also we have to find the centroid. Now what we have to do is uh, as we know, since we have two class, C for China class, it is represented by yes, and C bar for not China class, it is represented with no. Then step one. In step one, we have to find the IDFs. IDF, you know, inverse document frequency, right? So we have already discussed how to find inverse document frequency in our vector space model in fifth chapter, chapter number 5, right? So vector space model, we learned already how to find the IDF, inverse document frequency. So inverse document frequency for all the terms we are going to find here. Okay. So let us first see inverse document frequency IDF for Chinese and log n divided by DFT. So log this n is what? In inverse document frequency, total number of documents. So we have four number of documents, 1, 2, 3, and 4. And after that, what we have to find? DFT, document frequency. So let us check if Chinese is present in all the four documents. Chinese is present in D1, Chinese is present in D2, Chinese is present in D3, Chinese is present in D4. So document frequency for Chinese will be 4. That's why log 4 by 4 is equal to 0. Similarly, idea for Bayesian. Idea for Bayesian. For Bayesian also, a total number of documents n is 4 because we have only 4 documents. Then we will see the document frequency for Bayesian. Document frequency for Bayesian, it is there only in B1. So the document frequency will be 1. That's why we have written here 4 divided by 1. So log 4 it is 0.46. So you can calculate by yourself and cross check the values whether you got the same result or not. Similarly, for idea for Shanghai, idea for Macau, idea for Tokyo, idea for Japan, I have already uh, shorten this because all this document frequency For Shanghai, it is 1. Document frequency for Macau, it is 1. Tokyo, it is 1. Japan, it is 1. So, it will be similar. The calculation will be similar. So, log 4 by 1, this is 0.60. Why? Because you see here, Tokyo, it occurs only in D4. Japan, it occurs only in D4. Macau, it occurs only in D3. So, one time, one time, one time. Beijing, one time. Shanghai, one time. Macau, one time. Tokyo, one time. Japan, one time. That's why the document frequency for these respective terms is 1. Then for finding IDF, it will be 4 divided by 1. Log 4 divided by 1, so it is 0.60. So this document frequency for Chinese, it is 4. Explanation is also given in this calculation. Since Chinese is present in D1, D2, D3 and D4, and DFT for Chinese, it is 4. So capital N, this is the total number of documents in our collection. It is 4. Document frequency for Beijing, it is 1. So explanation is given here. So from this also you can check it, how it is calculated. Now in step 2. So in step 2, we will be calculating the TF score. We will be calculating term frequency score. So term frequency score, it is calculated here. How? It is using this formula. So the above T score is newly calculated using the formula, because here if your term frequency is greater than 0, then we will be calculating a new TF score. So this is not the TF IDF, or where is it? So this is not the TF IDF, this is the new TF score. So new TF score we are going to calculate using this formula. Why we are calculating new TF score? Since the terms are not present in D5. So suppose for D5, not all the terms are present. Macau is not present, Beijing is not present, Shanghai is not present. So we are calculating a new TF score. Okay, new TF score. So new TF score is calculated here by using this formula. TF equal to 1 plus log TF TD, term frequency for the term in the document. So TF for Chinese, it is 1 plus log 6. So term frequency for Chinese, let us check how many times it occurs. Term frequency, this is not the document frequency. So for term frequency, that means we have to count the repeated terms also. So Chinese, it is 2 times in document 1. It is again 2 times in document 2. So 4, then 1 time in D3, 1 time in D4. So 6. Chinese how many times? 1, 2, 3, 4, 5 and 6. So Chinese term frequency, not document frequency. For Chinese, the document frequency is 4, but the term frequency, that means if it is even repeated also, you have to count the frequency. So for term frequency, it is 6. That's why I am writing here log 6. 1 plus log 6, the number of times Chinese occurs in the collection D1 to D4. The explanation also it is given here. Okay. So log 6. So this term frequency 6, how it comes? It is nothing but the number of times Chinese occurs in the collection D1 to D4. It is 6. That's why log 6. So after calculation, I got 1.77. So if Japan, the term frequency for Japan, Tokyo, Shanghai and Macau for this new TF score will be log 1, because it occurs only one time in the collection. So 1. So our new TF score will be this one. Okay. So for Chinese, our new TF score is 1.77. For Japan, Tokyo, Shanghai, Macau, it is 1. So here. So since in for D1, if you calculate in D1, it is not there. Japan is not there in D1. So you can see here, Japan is not there in D1. That's why it is 0. It is 0 here. For Tokyo also it is not there. For Macau also it is not there. So 0. For Beijing it is there. So for Beijing it is there in D1. For Beijing the new TF score. For Beijing the new TF score is 1. For Beijing the new TF score is 1. So we are writing 1 here. So since the terms are not present in D1, why? For Japan, Tokyo, and Macau. For this, it is 0. Shanghai also it is 0 because they are not present in D1. Now coming to D2, you can check here. Coming to D2, we have only Chinese, Shanghai. So we will be having only these three values, others will be 0. So you can see here Chinese, then Shanghai. Since we have two Chinese, so only one Chinese we can write here because the terms Chinese, Japan, Tokyo, Macau, Beijing, Shanghai, these are the unique vocabulary terms. So this is how you do in your Boolean retrieval method, writing the this document term incidence document matrix. So in term incidence document matrix, what you have done? If the term is present, you write 1. If the term is not present, you write 0. Right? The same way here, instead of writing binary representation zeros and 1, we are calculating the TF score using the formula given here. Okay. So by calculating the TF score for Chinese, it is calculated here. We got 1.77. That's why we write 1.77 TF score for Chinese. So for Chinese, all this D1, D2, D3, D4, it will have TF score 1.77. And the remaining values, if the term is present in the particular document, it will be 1 because calculation for TF score for those term occurrences one time only, we got TF score as 1. So in D2 only Shanghai is there, so 1. Others will be 0. 1 second. Hello. Sir. Sir. I disable offline tong na. The 16 days sa 20 ga kanyobok o yung tawag 4 20 ga 5 admire o yung tawag. Moiga academic calendar da follow tawag na to sa. 16 day hawagidi May. Timetable ꯑꯣꯏꯅꯗꯤ ꯄꯤꯗ꯭ꯔꯤ academic ꯀꯩꯅꯣꯗꯗꯤ ꯁꯥꯔ 16 ꯍꯧꯋꯦ ꯑꯗꯨꯒ ꯗꯦꯠ 20ꯒ 4ꯔ 20ꯒ ꯀꯩꯅꯣꯔ ꯑꯃ 6 ꯑꯃꯗꯤ ꯑꯣꯏꯕꯅꯤ 20 ꯀꯌꯥꯕ ꯁꯥꯔ ꯑꯥ ꯑꯗꯨꯗꯤ ꯉꯟꯅ ꯂꯣꯏꯔꯛꯑꯅꯤ ꯍꯣꯏ ꯁꯥꯔ ꯑꯣ ꯃꯣꯏꯒꯤ ꯑꯦꯟꯇꯥꯝꯒꯤ ꯀꯩꯅꯣ ꯇꯥꯏꯝ ꯇꯦꯕꯜ ꯀꯩꯀꯥꯗꯣ ꯑꯩ ꯍꯪꯉꯒꯦ ꯑꯗꯨꯒ ꯎꯝ 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 ꯍꯣꯏ ꯁꯥꯔ ꯌꯥꯏꯌꯦ ꯁꯥꯔ ꯑꯗꯨꯕꯨꯗꯤ ꯑꯗꯣ ꯁꯥꯔ ꯀꯩꯅꯣꯗꯤ ꯍꯥꯏꯔꯛꯑꯣ ꯃꯦꯗꯥꯝ ꯖꯤꯅꯥꯅ ꯁꯥꯔ ꯍꯥꯏꯐꯦꯠ ꯅꯍꯥꯟ ꯀꯩꯅꯣ ꯁꯥꯔꯗꯁꯨ So, okay, now this is for TF score, right? So TF score, just like how you do in binary incidence matrix. If the term is present, you are writing 1. If the term is not present, you are writing 0. So the same case we are applying here, but instead of writing 1 and for the presence of the term, we are calculating the TF score using this formula and substituting the values. That's all. Okay. So if the term is not present, obviously we are going to write 0, because when you calculate here, if the term is not present and where is it with the term? So say, for a particular term, if there is no presence, it will be 0. No need for calculation. Say, for example, in document G1, Chinese, Beijing and Chinese. So you can calculate for Chinese and Beijing alone. You don't need to calculate for Shanghai, you don't need to calculate for Macau, you don't need to calculate for Tokyo. So only for the term in the document you have to calculate here. So Chinese and Beijing you have to calculate. For Chinese it is 1.77, for Beijing it is 1, and the rest of the terms in the table it will be 0. Then for term number 2 or document number 2, you can calculate for Chinese and Shanghai. So the other will be 0 in the table like this. So we for D2, Chinese and Shanghai all alone. So since the terms are not present in D2, other values will be 0. And for D3 also, we have 1.77 for Chinese. Tokyo and Japan is not there, so 0. Macau is there in D3, so for Macau it is 1. Beijing and Shanghai it is 0. Now for D4, Chinese is there and Tokyo, Japan is also there. So others are not there, others will be 0. So Tokyo and Japan 1 1. Macau, Beijing, Shanghai is not there, so it is 0. Similarly for D5. For D5, you have to calculate the term score for Chinese, Tokyo and Japan. So for Chinese, it is 1.77. For Tokyo and Japan, it is 1 and 1. Macau, Beijing and Shanghai, they are 0 since the terms are not present in D5. Now, step number 3, TF-DIDF score. So term weighting. So this is known as term TF-IDF score, where you need to multiply the term score along with the IDF. So the same table from this you can use here. So with this, you have to multiply along with IDF for Chinese, IDF for Japan, IDF for Tokyo, IDF for Macau, IDF for Beijing, and IDF for Shanghai. That's what it is done here. So IDF and TF score. So you can see in the table, IDF for Chinese is 0. Term score for Chinese is 1.77. Then for Japan also same thing. TF and IDF you have to multiply. TF and IDF you have to multiply. The other terms are 0. You can check for Beijing. So for Beijing, the IDF value, the initial one which we have calculated here. So for Beijing, it is 0.60. So 0.60 into TF for Beijing. So what is TF for Beijing? It is 1. Now, here 1 into 0.06. TF is 0.06, IDF is 1. Then 1 second for Beijing. Let us check once again. For Beijing, mm, for IDF is 0.60. Okay, IDF is 0.60 and TF is 0 in D1. In D1. So in sorry in you have to see this table for step 2. This table you have to see. So here it's a directly you can multiply. So for Chinese it is 1.77 into you multiply the IDF value for Chinese. Okay, so IDF value for Chinese is 0, so you will get 0 in the next table. For Japan it is already 0 here, 0 with IDF is also 0. IDF sorry, this is TF score. TF score is 0. IDF for Japan is 0.60. IDF for Japan is 0.60. So 0.60 into TF is 0. It will get 0 in the next table. For Macau also it will be 0 because 0 multiplied with any number will be 0. For Beijing the TF score is 1. So 1 multiplied by IDF. IDF is for Beijing the IDF is 0.60. So 1 into 0.60. So that is what it is written here. 1 into 0.60. So it is you do one thing. 0.60 down I'm writing TF, so it should be IDF. Okay, and below 1 I'm writing IDF, it will be TF. Okay, it will be TF. So you change this one. Okay, all of you change this one because 0.60 is the IDF value, not the TF score. TF score is 1. So you have to interchange these two terms here. Instead of writing IDF, you write TF. Instead of writing TF, you write IDF. Okay. Like this, you have to multiply here in this term score, TF score along with the IDF. And this is the result I'm getting here. Okay, after multiplying TF along with IDF, I'm getting this table. So TF with IDF, you have to multiply for all the documents, including the test document also. So including the test document is multiplied and we have calculated a table like this. Okay. Now step number 4, representing document as vectors. So here what we have to do is just we will be writing, representing this document as vectors. For this also you can see here. So representing into vector, we need to calculate this formula. So you can see for Beijing here 0.60, it is nothing but you can see the right side here for Beijing. For Beijing, for Shanghai, it is 1. How? The calculation is given down here. So this is representing the document into vectors. For representing the vectors, we have to calculate like this. Okay. So this calculation, similar calculation we have done in our cosine similarity also, where we do a dot product and Euclidean distance. Okay, so that same formula we have applied here, and numerator we are writing the TF IDF score, and denominator we are writing the TF IDF score of all the terms in that particular document. Okay, so first one 0 square, it is for TF IDF score of Chinese. Next 0 square is TF IDF score of Japan. Next one is Tokyo, Macau. For Beijing, TF IDF score is 0.60. So we are writing the value from here. TF IDF score is 0.60. So this one plus 0. So after calculation of all this, I am getting 1. Here, document vector for Beijing, document vector for Shanghai, we are getting 1. So like this, you have to calculate for all the terms, and this is the value I got after calculating the document as vector. Okay, so this is the value I'm getting. Now, this is again explanation for other calculation for Japan, for Tokyo, all the calculations. Explanation is given here. Then centroids. How to find the centroids? So centroids, as you know, this is the center of the three documents. So D1 vector, D2 vector, D3 vector. Since there are three yes classes for centroid for yes class, mu c, mu c is for yes class. So we have to find in this way: document vector 1, document vector 2, document vector 3 divided by 1 by 3, since we have three classes. So for all these three, we got 0. So this is for Chinese. Then similarly for Japan and Tokyo, it will be in the same way. For Chinese, for Chinese, for Chinese. For Japan in D1, for Japan in D2, for Japan in D3. So like this, for all the terms we have to find. Then for Macau, say 1 by 3, 0, 0, 1. Because in D1 vector, D1 for Macau it is 0, in D2 vector for Macau it is 0, and in D3 vector for Macau it is 1. So we got 1 by 3, which is 0.33. Similarly, the calculation is done for other terms in the document. Now this is what we got for Chinese, for Japan, for Tokyo, for Macau, for Beijing, for Shanghai. Similarly for North China class, for Chinese, for Japan, for Tokyo, for Macau, for Beijing, for Shanghai. And after that, this is a very long step, okay? Then after that, we have to find the distance. We have to find the distance of the test document from the centroid. Okay, from the centroid. So, mu c minus d5. Mu c minus d5. Document as a vector. So, mu c, what are the values we got here? So, this 0, 0, 0, 0 0.33, 0 0.33, 0 0.33. And for D5, D5, where is it? D5, D5 here. D5, we got 0, 0 0.71, 0 0.71, 0, 0, 0. So these two values we have to find the distance. That means subtract. After subtraction, we got, where is it? Here. 0 minus 0, 0 minus 0.71. So this D5, this value. So we got 2.71. So here also I have written here for D5 document vector values are written here. For mu c, the values are written here. So you can directly subtract using these values and we got 2.41. Similarly, you find for North China class, mu c bar minus document vector 5. So here mu c bar minus document vector 5 d5. Then after calculation we got 0. So since we got 0, if the distance is 0, it means that it has the minimum distance. It has the minimum distance. That's why we will be assigning D5 to North China class. So we will be assigning D5 to North China class. So since C2 is nothing but our North China class, second class, has the minimum distance with D5, D5 is assigned to C2 class. So therefore, our new document D5 belongs to North China class. Document D5 belongs to North China class. And separating hyperplane, some formulas are written up there. So that formula is written again here, W vector, X vector. So this W vector is calculated using mu of C1 minus mu of C2. That means the two centroids for China class, difference of the two centroids for China class and not China class. We have to find the difference. After finding the difference, I got W vector as this one. Okay, 0 minus 0.71 minus 0.71, 0.33 and so on. Now calculations, W vector minus X vector. So X vector is nothing but our document vector. So this X, it will be represented with D1, it will be represented with D2, it will be represented with D3, like this with all the documents up to D4. So WT already we have calculated the values here. Then D1 also we have already calculated in the previous table. We substitute the value, do a dot product here, and we got this value. So for D1, the separating hyperplane equation, using the equation for D1 we got 0.33 after calculation. Okay, and for D2 we got this one. Similarly, up to D4 we have calculated, and finally we will be computing B. So B is some here will be written. So this B, okay. B is a constant. So this constant value we will be computing here. How we got this constant value? So that one again. Here, computing B, we have to use this formula. 0.5, a constant value, then absolute of centroid for C1 square minus absolute for centroid for C2 square. C2 is not China class, C1 is China class. This one we have to compute again. So mu C1, mu C2 already calculated. Mu C1, mu C2, the two central values here. So these two already calculated using this 0 minus 0 square, 0 minus 0.71 square. That one we are calculating here. Okay, that value we are calculating here, and the result multiplied with 0.5, we got minus 0.33. So our constant value B is calculated, and we got minus 0.33. And finally, this B we have to compare with W vector, X vector, then we can separate the hyperplane. So comparing B with each W vector, X vector document in C are above hyperplane, since this value is greater than B, and documents in C dash are below hyperplane since this value is less than B. So we have two hyperplanes here. The documents in China class are above the hyperplane, and documents in North China class are below the hyperplane. Then, as I told you, the assignment of the classes will be different according to the different classification methods. In Bayes method, the particular example we have assigned to China class, and using Bernoulli's we have assigned to North China class, and vector space Rocchio classification we have assigned to North China class. So that means sometimes according to the classification method you choose, the assignment of the classes may be different. So, Rocchio classification, this gives more importance on correspondence or nearest neighbor with the label documents and unlabeled documents. So once again, let me explain this, a brief explanation about vector space classification. So in vector space classification, as I told you, there will be reasons for separating the regions of separating the different classes, and that the reason, the line which separates the or the region which separates the different classes, they are known as the decision boundary. So you can see here three classes, the line drawn here to separate the three classes, they are known as decision boundaries. So we have two types of method for vector space classification. First method is Rocio's classification, and the second one is nearest neighbor classification. So Rocio's classification, here in this we used to find centroid. Centroid is nothing but the center of the document we are going to find, and it will be computed for different classes. If there are two classes, centroid will be computed for two different classes. According to this example we are discussing today, we have two classes, China class and not China class. So we will be having two centroids, one for China class and the other one for not China class. Then after that, what we have to do is, we will come to the example here. So this example, for the past 3 days, we are doing the same example so that you can know the difference between the different methods. Okay. Now, this table is nothing but what? This is the IDF values. This is the, not the IDF value, this is the final value. Okay, final value after calculating the vectors. So before calculating the vector, let us see how this table comes. Okay, first step is to find this table. Slide number 10 table is equal to slide number I'll show you this one. Okay, this table, it is equal to with this one. Okay, without the mu1 and mu c. So it's slide number 16 and slide number 21 together. The table is represented here. Okay, in slide number 10. 16 and 21 slides, the final result for both, it is represented here. But let us see how this table is being calculated. First one, we have to find the IDFs. Okay, IDF is nothing but what? IDF is inverse document frequency. Since I told you, in Rocio's classification, we have to find the centroids for two classes according to this example. Centroid for yes class or China class, centroid for not China class. And also these two classes we can represent by giving some variable names C1 and C2 also. Now first step is to find the IDF. So IDF finding, the same formula, log n by DFT. DFT is the document frequency, and when I say TF, TF is the term frequency. So IDF calculation we have already done. So for the respective terms, we have calculated the IDF values. Now it comes second step. Second step is to find the TF score. TF score is newly computed using this formula. If our term frequency is greater than 0, then if it is equal to 0, we are not going to calculate. Okay, it is not necessary to calculate if it is equal to 0. But if the term frequency is greater than 0, then we will be calculating the new TF score using this formula. So new TF score 1 plus log term frequency. So for Chinese, from document 1 to T4, it occurs 6 times. So log 6, and it is calculated here. Similarly, for Japan, Tokyo, Shanghai, Macau, it is calculated and we got 1. So those values are substituted in this table. Okay, all the IDF value, all the TF values are calculated and it is substituted in the table. If the term is, if the term frequency is 0, then no need to calculate. Directly we can write zeros here. That's why I'm writing Japan, Tokyo, Macau 0 in D1. Okay, because in D1 the terms are not present. So term frequency is equal to 0. So no need to compute term frequency, term TF, new TF score for Japan, Tokyo and Macau in D1. Because in D1 these terms are not present. Okay, only we have Chinese and Beijing in D1. Similarly, in D2 also, Japan, Tokyo, Macau, Beijing, these are not present. So TF is 0. So we don't need to calculate the new TF score for these terms. So only if it is present, we are going to calculate. Okay. Now the table is here. This is the new TF score table. And after that, we will be finding TF IDF score. So IDF it is already calculated. TF is calculated here. You just multiply both the values and you got this table. Okay. And here a small change for Beijing in D1. IDF, here I have written IDF down to 1. So here you have to write TF and in 0.60 you have to write IDF. Okay, you have to change this one. So this is a new table for TF IDF 4. And after this, we have to represent document as vectors. So in order to represent document as vectors, we need to compute this one. Okay. So this is also already there in the formula how to calculate this. So for Beijing, Shanghai, and for all the terms in each document, it is computed using this formula. So in the numerator, we are going to write the TF IDF score, and in denominator, we have to write for D1, if you calculate for Beijing, then you have to use this one. Okay. TF IDF score you have to write denominator. You have to write for Chinese, for Japan it is 0, for Tokyo 0, for Macau 0, for Beijing it is 0.60, for Shanghai it is 0. So that is what it is written here. So only in the Beijing we have this square, other values are 0. So similarly for Beijing, for all the terms in all the documents, you have to check the respective documents and calculate the vector values. Okay. Now, after calculating the vector values, this is what we got. And now, these are other explanations for calculation. So it is very easy. You can just go through once. And for calculating the centroid, here, for centroid also for each term you have to calculate. So document vectors we have calculated already for D1, D2, D3. It is already calculated here, D1, D2, D3. That values we will be substituting in calculation of the centroid values. So for Chinese, 1 by 3, 3 because 3 classes for China. So D1, D2, D3. Okay. For Chinese, D1 in D2 and in D3. So you have to find from this value. So in Chinese in D1 it is 0, Chinese in D2 it is 0, Chinese in D3 it is 0. So here, okay, for Chinese it is 1 by 3, 0 plus 0 plus 0 equal to 0. Then we have to calculate for Japan also in the same way. Now for Macau, it is 0 plus 0 plus 1 because document vector for Macau in D1 is 0, document vector for Macau in D2 it is 0, document vector for Macau in D3 it is 1. So 1 I have written here, calculations are done. Okay, calculations you have to do similar way. Then this is the final value we got for mu C and mu C gas. Mu C and mu C gas for China classes. The centroid values we got for the respective terms are given here. And for mu C gas, the respective values are given here. And after that, you have to find a distance. The fact concept is similar. Okay, this is finding the distance. And in probability method, we find the probability. Here in vector space, we find the distance. So d5 with mu c, d5 with mu c gas, we have to calculate. Okay. So this is with mu c, we got 2.41, and with c gas, we got 0, which means it has the minimum distance. So the classifier, vector space classifier, will assign d5 to C gas class, which is our North China class. And next step is to find the hyperplane. This is a formula already we have seen in the previous slide, that formula. So we have to find what are right side values and left side values. So W vector, which is calculated using the differences between the centroid values for C1 and C2. So it is calculated. We got W vector here. Then again x vector is are all the documents, document D1, document D2, document D3 and document D4. So you do a dot product and find this dot product value. So it is 0.33 with D1, with D2 it is 0.33, with D3 it is 0.33, with D4 it is minus 1 point something it comes. Okay. So that value we will be using for our calculation purpose. Next, computing B value, we use this formula and this mu C1, mu C2, absolute square. So mu C1 already it is calculated, mu C2 it is also calculated. You do the subtraction and we got 0.33 for B. B equal to minus 0.33. So comparing B with each W1 D vector. X vector is nothing but D vector. So we will check here for the first one. See here for D1 it is 0.33. Our B is minus 0.33. So you check these two values, compare these two values. And here also with D2 it is 0.33. Our B is minus 0.33. So this value is greater than our B value. This value also greater than our B value. And third one also D3 is 0.33. 0.33 is greater than our B value because our B value is minus 0.33. So these three values D1 and D2, D3, they are above the hyperplane. And above D4 it is minus 1. So minus 1, that means our V value is greater than this D4 W vector, this value minus 1. Okay. So we can separate these four documents into two separate hyperplanes. That means we have to compare B with this value, and documents in China class are above the hyperplane because they have those values greater than B, and documents in B C2, which is not China class, are below the hyperplane because this vector value is lesser than B. Okay, because here all up to D1, D2, D3 we got 0.33, which is greater than minus 0.33. Whereas in our North China class, our W vector, document vector, this value we got only minus 1 0082. So which is lesser than minus 0.33. That's why it is below the hyperplane. Okay. So once again, you go through this Rokyo classification today. If you have any doubts in the calculation, you can ask me tomorrow. But before that, you have to go through once because I know many of you won't be listening to this class. So just go through this topic once. Then, if you have any doubts, you can ask me tomorrow. Okay. So for today, let's wind up here. Before that, I will take a quick phone call.